Hello, it's Mr. Epps here, and we're going to do some right triangle applications along with reintroducing sine law and cosine review from the past. Okay, so let's take a look at this problem here. It says that a ship is travels from a lighthouse in Ropstown 70 kilometers on a bearing of 57 degrees. Oh, I have to remember what bearings are. And then travels on a bearing of 147 for 180 kilometers, ending at a dock in Flynnville. Okay, so remembering this is our scenario. This is north. This is north. So if I am going, the ship travels from a lighthouse in Ropstown for 70 kilometers, a bearing of 57. So if this is Ropstown, bearing of 57, always from north in a clockwise direction. So this is going to be 57 degrees at a bearing. And this is 70 kilometers. Then at this point, after 70 kilometers, it turns out a bearing of 147. So again, I can put a north, south, east, west line on there. I can put this kind of a line on anywhere. And I know these lines are parallel. Again, this is north. And so I'm going to go 147 down for 140 degrees. And when I make these diagrams, I try to make them somewhat reasonable. They don't have to be exactly true, but somewhat reasonable so I know I don't make careless mistakes. So that here is 147. It also helps when I'm proportional to help see where the angles are. Okay, so I need to see what I have here, and then I want to find the distance from Roxville to, here's Flynnville. I want to find this distance here. Okay, I want to find what RF is. Well, let's work at these angles a little bit. If I know if this is 57, well then this part here is also 57 because they are parallel lines here, because they're both north. And if this is 147, then this part of the angle, if I subtract 180 minus the 147, I get 33. If this is 33, in total then, this is a 90-degree angle. If I add 57 and 30, just double checking that, convincing everyone here that it's 90. And so conveniently, this is a right triangle. And I am looking for this distance here. Well, if I want to find RF, it's the hypotenuse, so I'm going to square it by using Pythagorean theorem. I can calculate what RF squared is, and from here I can calculate RF. I just go the square root of 70 squared plus the 180 squared, and that gives me 193 kilometers to 3 significant figures. Okay, and so now the second part is, what is the bearing from Flynnville to Ropstown? So here's Flynnville. Again, I'm looking for the bearing. I need to make the bearing come all the way around to here. So to help me out, if I could find this angle theta, I know from, again, parallel lines, I do the alternate interior angles here, that z figure. This angle here is 33. So if I can find theta, subtract it from 360, and I have my angle. So in order to find my theta, again, I recall, here's theta, this is my opposite, this is my adjacent. So opposite over adjacent is the tangent of theta is equal to 70 over 180. And so then theta, checking to make sure that I am in degrees. I'm going to keep it in degrees because typically triangle trig is in degrees. And I'm going to go second tangent of 70 divided by the 180. And so theta is 21.25 degrees. And so if I want to find the bearing is going to be, 360 minus 33 minus 21.25. So 360 minus this answer minus 33 gives me a bearing of 306 degrees to 3 significant figures. Okay, so we've used Pythagorean theorem, we've used basic right triangle trig, and we've reviewed bearings.